The math behind human irrationality. Humans like to believe they are logical, deliberate, and rational, carefully weighing options before making choices. Yet again and again, their decisions follow patterns so predictable that mathematics can forecast mistakes before they are made. What feels like free choice often turns out to be a formula quietly steering behavior, revealing that irrationality is not random chaos, but structured, repeatable, and strangely consistent. To understand why this matters today, we need to confront an uncomfortable truth. Modern life is built on the assumption that people act in their own best interest. Markets rely on it. Democracies depend on it. Education, health, and technology all assume that better information leads to better decisions. And yet, evidence keeps proving otherwise. People ignore better options. They cling to bad investments. They fear small risks while embracing catastrophic ones. They overvalue what they already own and undervalue what they do not. These behaviors are not rare. They are universal. For a long time, these patterns were dismissed as flaws, noise, or weakness of character. Irrationality was treated as a failure of discipline or intelligence. But when researchers began measuring decisions carefully, something unexpected appeared. The mistakes were not scattered. They clustered. They repeated. They followed rules. Mathematics stepped in not to judge, but to describe. It showed that humans systematically violate classical logic in the same ways, under the same conditions, across cultures and contexts. People fear losses more than they value gains. They prefer certainty over better odds. They anchor on irrelevant numbers. They trust recent experience over statistical reality. What made this shocking was not that humans were irrational. It was that their irrationality was consistent, predictable, measurable, and therefore mathematical. This discovery changed everything. If irrational behavior followed patterns, then choice was not purely psychological. It was structural, built into how humans process information, time, risk, and reward. Bias stopped being an accident. It became a feature. In the modern world, this matters more than ever. Algorithms exploit these patterns. Marketing amplifies them. Systems are designed around predictable mistakes. What feels like personal failure is often engineered inevitability. The real question is no longer why humans are irrational. It is why these patterns exist at all. And what happens when mathematics understands our minds better than we do? Once these patterns were identified, researchers stopped asking why people occasionally make bad decisions and started asking why the same bad decisions appear again and again under remarkably similar conditions, even when people are warned in advance. The answer was unsettling, because it showed that irrationality is not a glitch that appears under stress, but a default mode that operates quietly beneath conscious reasoning, shaping choices before logic ever has a chance to intervene. Mathematical models reveal that the human mind does not evaluate outcomes in absolute terms, but relative to reference points that shift constantly depending on context, expectation, and recent experience. A small loss feels devastating if it comes after a gain. A modest gain feels disappointing if a larger one was imagined. Value is not fixed. It bends around emotion. This explains behaviors that once seemed absurd. People refuse fair trades because they feel unfair. They take dangerous risks to avoid certain losses. They hold on to failing projects long past rational exit points. The math showed that losses weigh more heavily than gains, not slightly, but dramatically, creating asymmetry at the core of decision-making. Time distorted reasoning even further. Future rewards were discounted aggressively. Immediate pleasure outweighed long-term benefit. Certainty today felt safer than improvement tomorrow. Mathematics described this as inconsistency, but emotionally it felt natural, even responsible. Probability fared no better. People treated unlikely events as impossible until they happened. Then they treated them as inevitable. Risk perception oscillated wildly, untethered from actual likelihood. The numbers stayed stable. The feelings did not. What shocked researchers most was how resistant these patterns were to education. Knowing the math did not eliminate the bias. Training did not restore rationality. Awareness helped slightly, but structure always won. The system defaulted back. This meant irrationality was not ignorance. It was architecture. The brain had evolved to survive immediate threats, not to optimize abstract outcomes. Speed mattered more than accuracy. Emotion mattered more than probability. Shortcuts were necessary, even when they misfired. Once this was understood, the problem changed. The question was no longer how to fix human irrationality. It was how to design systems that account for it without exploiting it. And that question would soon expose a much darker side of mathematical insight. This is where the conflict becomes unsettling, because once irrationality was mapped mathematically, it stopped being a human weakness and became a strategic resource that could be measured, predicted, and deliberately activated. If mistakes follow patterns, then those patterns can be engineered around, nudged, amplified, and exploited in ways that feel invisible to the person making the choice. Markets adjusted first. Prices were framed to emphasize losses rather than gains. Discounts were timed to trigger urgency instead of value. Options were arranged so that the irrational choice felt natural, while the rational one required effort. Nothing was forced. Everything was guided. Technology followed quickly. Interfaces were designed around attention decay. Notifications exploited fear of missing out. Endless scrolling fed loss aversion and variable reward. Engagement grew not because content improved, but because behavior was mathematically anticipated. This revealed a moral fault line. When systems understand human bias better than humans do, responsibility shifts. Are people still choosing freely if every option is shaped to trigger predictable weaknesses? Is consent meaningful when environments are optimized to bypass deliberation? The math offered no comfort. It showed that small nudges compound. Tiny biases repeated millions of times reshape behavior at scale. Individual choices look harmless. Collective outcomes become extreme. Freedom erodes quietly, not through coercion, but through design. Even more disturbing was how effective these techniques were. People defended their choices passionately. They felt autonomous. They felt rational. The mathematics worked precisely because it stayed invisible. This created a new asymmetry of power. Those who understood the equations could steer behavior. Those who did not became predictable variables. Rationality no longer protected against manipulation. In some cases, it made people easier to guide. Attempts to regulate this lagged behind. The systems moved faster than ethics. By the time harm was visible, habits were entrenched. Dependency had formed. Reversal became difficult. The conflict was no longer about irrationality itself. It was about ownership. Who controls the patterns of human decision-making? Who decides when influence becomes manipulation? And whether mathematics, once a tool for understanding behavior, had quietly become a mechanism for shaping it. At this stage, irrationality stopped being an internal flaw. It became an external vulnerability. And recognizing that vulnerability forced a final, unavoidable question. What responsibility comes with knowing exactly how people will choose before they do? The climax of this story is not the discovery of irrationality, but the moment humanity realized that understanding the math behind its own behavior came with power that could either protect autonomy or quietly dismantle it. Once decision patterns became predictable, the future of choice stopped depending on free will alone and started depending on who designed the systems surrounding that will. The resolution begins with responsibility. If humans are not purely rational, then ethical systems cannot assume they are. Design must compensate for bias, not weaponize it. Transparency must replace manipulation. Choice must be protected, not engineered. This reframes progress. Success is no longer about maximizing engagement, profit, or efficiency at any cost. It becomes about alignment. Do systems help people choose better or merely choose predictably? Do they strengthen agency or quietly hollow it out? Mathematics itself is not the villain. It revealed truth without judgment. The danger lies in asymmetry. When one side understands equations and the other does not, influence becomes invisible and accountability disappears. Power concentrates quietly. The solution is not abandoning insight. It is democratizing it, teaching people how their minds work, designing friction where manipulation thrives, building environments that slow decisions when stakes are high. Irrationality does not need to be eliminated. It needs to be respected. It evolved for survival. It carries wisdom alongside error. When acknowledged openly, it becomes manageable. When denied, it becomes exploitable. The math behind human irrationality ultimately delivers a warning. Understanding behavior grants influence. Influence demands restraint, and restraint defines maturity. The future will not be shaped by who knows the equations. It will be shaped by who chooses how they are used. Sometimes the smallest shift in perspective becomes the beginning of a new future. The